Today we are talking about the solubility product constant. Okay, this is known as KSP. This is known as KSP. This is you too.
What?
Talking about the solubility product constant. Okay. KSP. You didn't listen. Okay. It is the equilibrium constant for the process of dissolving an ionic substance dissolving in water. Now, we know that things that are soluble based on those solubility rules always dissolve in water. So you don't have a KSP for, say, a nitrate, sodium nitrate. Yes, ma'am. You don't have a KSP for a sodium nitrate because it dissolves 100% of the way, and that's just a stoichiometry problem. So its symbol is KSP. KSP, the solubility product, and K being a constant with an equilibrium constant. We treat this just like an equilibrium constant. Okay, this is still products over reactant. This is still products over reactant. So how would I write the K expression for this equation?
K equals bracket A, bracket B, bracket over A.
No.
You want me to say that whole thing?
Yeah.
Not over AB.
Not over AB, because it's a solid.
You let me say
Because
that whole thing.
the only thing got me wrong was incorrect. The last thing you said. So it is not including. So the KSP or the K, however you want to talk about, does not include the AB because it is a solid. Okay, the solids and liquids are not included. Solids and liquids are not included in a K expression. Okay, only aqueous solutions and or gases. Okay, so it's the same thing that we had done. So this one, what would be the K expression for this example? What?
Come on now. Okay, it's brackets BA 2 plus brackets. That's a bracket already. And so for my brackets over brackets BaSO4.
No, it's not over BaSO4. It's solid, okay?
I swear that said A.
And I don't have a great example of this, but if this would have been a 3 here in front of BA, this would have been a 3 in front of BA, BA would have been the third power, okay?
So you always include the targets.
In this one you do because they are ions, because we're dissolving in water, so they ionize, okay?
I thought ions were positive.
So now
Ions can be positive or negative. What?
Now we're working with aqueous solutions and not.
This is, we were working with aqueous solutions or gases,
Yeah,
okay?
and
Now we're working exclusively with just aqueous solutions, okay?
I swear when I saw the S, I thought of solution.
Solid. AQ stands for aqueous solution. So just a few review of things, and this will go into what we're going to learn tomorrow, which is the last thing we'll do tomorrow. Solubility, unsaturated means it's not full of solute. Okay, you can add more solute. The solute will dissolve. Saturated means that it's full of solute, so if you add more, no more will dissolve. Okay. Supersaturated is a solution that holds more solute than it's supposed to hold. These are unstable. I'd say most people have done this in your life. You've made a supersaturated solution when you were growing. Let's say, did you all ever like grow crystals in elementary school or things like that?
Oh, crystals.
I never grew crystals.
No.
In elementary school, it was pitiful.
Did you do a crystal? We didn't do the egg thing or anything.
I mean, I remember doing like St. Henry's, like we put some stuff in there, we heated it up.
Who was your teacher?
Mrs. Moxley.
We blew stuff up.
And then you just sit it out, and as the liquid dissolves, the crystals grow. Okay.
I have this box.
So that's talking about crystallized until the solution becomes saturated. Crystallized. And then molar solubility is the amount of solute that will produce a saturated solution. Okay. A saturated solution.
You know what I just realized?
Its common units are either moles per liter, or I would say it's probably more typically be given in grams per liter. The molar solubility of substances is known. Okay, you can Google the molar solubility of a substance. Okay, you can Google that. So our first KSP example. So here's our first example. I'll give you a chance to write it down. These are icebox problems. These are icebox problems. All right, so to do this, okay, this is an icebox problem. Calculate its KSP value. So in order to write the KSP, you need a chemical equation, don't you? So what is how would you write copper 1 bromide dissolving in water? What would that equation be?
Easier.
CuBr, solid, so we know that's a solid.
Solid, and then would it be like arrow first or would it be
Arrow,
arrow H2O?
no.
Arrow CBR
Cu plus Br minus, so both those are aqueous solution. So our K expression would be Cu times Br, okay?
Wait, what was the equation?
CuBr solid yields Cu plus Br minus, and both the products are aqueous solution. So we need to fill this icebox problem out. Okay, what's my initial concentration of? What is my initial concentration of Cu? What? Well, sorry, wait. What? I need to fill some stuff out. What do I know?
Hold on. It's taking a minute to write.
That's fine. We know all the I's. I will tell you that. What is the I of CuBr? It certainly is. What is the I of Cu and Br?
Wait, how do we know that?
Given right here, measured solubility. The I of Cu and Br is 0, isn't it? Because before it dissolves, there's nothing present, correct? So, if that much can dissolve, what's my change going to be? That much. I'll minus that from there. And what am I going to do over here to these two? Add them. Because they have to add just like we did. Just like we did. Now, this doesn't matter, does it? The E of CuBr does not matter, does it? But we need to find the E of Cu and Br. So 0 plus that would give you that. 0 plus 2.0 would give something that would give you that. Now do I have enough information? Because I'm asked to calculate KSP. Now do I have enough information to calculate the KSP? Yes. You just plug, once again, you plug your equilibrium values into this expression. And that's it. And then you put it in your handy dandy calculator. And you get the KSP of being 4.0 times 10 to the negative 8. We definitely need it for your test on Friday.
What is our test on?
Equal
Maybe it'd be on our
Chromebooks.
quarter,
Yes.
or our quarter grade, I mean.
Yes, ma'am.
Equilibrium like this, icebox and the equation.
Wash out with your principal reaction quotient containing stuff.
Oh yeah, I need help from that Google thing. Also, Thompson, with that quizzes, I tried to do it without my notes and.
Next example, calculate the KSP values for bismuth sulfide, which has a solubility of 1.0 times 10 to the negative 15th. What's getting done, you're talking pretty much in this unit, where if you have a question, you probably need an icebox. Unless it's already at equilibrium, which this is not. Let's start filling out this icebox, okay? First thing to be able to do the icebox, we probably need an equation, don't we? So what would our equation be of Bi2S3, what would it go to? No. 2 Bi3 plus 3 S2 minus, okay? Because we have to have a balanced equation on this.
Where is our equation?
So our equation would have been Bi2S3. Oh, yeah, I got something, that's fine.
Oh, it's 3.
So our equation, so there's our equation, because we have to have it balanced. Okay, we uncross the charges. Hey, does the real charge of here 3 plus really matter? No. Okay, that 3 plus doesn't really matter in this. That 2 minus really doesn't matter. I mean, it does in terms of the ions, that's what's there. It might start mattering a little bit tomorrow. So my equilibrium expression would just be Bi 3 plus squared S2 minus Q, because the coefficients become the powers. So now I'm ready to fill out my icebox. What's my initial concentration of something?
1 10,000
And that's the initial concentration of what?
BI 2.
Yes, ma'am. What are my initial concentrations of Bi 3 plus and S2 minus? 0. So what's my change? What's the change of Bi 2 S3? Minus 1 times 10 to the negative 15. What about a Bi 3 plus? No.
Oh, times 2.
You have to multiply it times 2 because the coefficient there is 2. And then if S, you'd have to do it times what? 3. So it'd be 3.0 times 10 to the negative 15. So my equilibrium expression is just I plus C. Okay. And once again, I don't need the Bi2S3. So 0 plus 2 times 10 to the negative 15 is 2 times 10 to the negative 15. And then 3 times 10 to the negative 15 plus 0 is just 3 times 10 to the negative 15. Now I'm ready to plug this into my equilibrium expression, aren't I? And just plug these in. Don't forget to square and cube these.
Did you go mark it? Ooh,
Grade your thing.
my name, please.
No,
Why not?
so my KSP is 1.1 times 10 to the, I will probably tomorrow morning. Is 1.1 times 10 to the negative 73rd. What this tells you is that this is not very soluble. This is not product favored because K is much less than 1, isn't it? Much less than 1. Keep in mind when we're talking about Avogadro's number, just an example, Avogadro's number being 6.022 times 10 to the 23. I mean, I forget the number. Like every person on Earth counted 1 atom per second. It would take like 7 million years to count that, it's Avogadro's number. So this KSP is very much reactant favored, so it's telling you it is not very soluble. Any questions about this example? Okay. All right, last example of this. So we've been solving for KSP. Now they're going to give us KSP, and we're going to have to solve for something else. So there's our question. I'll give you a chance to write it down and get your icebox ready. All righty, so I need to start filling some things out, don't I? So somebody tell me something I know. Dalen is correct. The I for solid is not X. No. I's aren't X's. I's aren't X's. So I know the equilibrium expression is this. Okay, everyone agree with that? That's our first step. Now, does it really matter what this is right now? Our KSP is not the I, is it? So that's usually a mistake most people make. They want to plug in 1.6 times 10 to the negative 49 right here. That's wrong to do. Okay, that is wrong. But what's my concentration of Ag and S before it dissolves? 0. So this is not, I don't care about any of this. All this is solid, not included. This is 0, and S2 is 0. Right. So now what's my change of Ag? 2x. Why is it 2x and not just x? It has a coefficient of 2 in front of it. What's my coefficient, what's my change of S? X. So this is still solid. I don't care about that. I mean, you don't have to really write this. You had to, the first one kind of shows you what they were. So what's my E of Ag 2 plus? Ag plus. 2x. And then this is x, correct? Now, do I have enough information to solve for x? Yes. Because I know my KSP, don't I? 2x squared times x, okay? 2x squared. So all I did was, this is the same thing we did at the end of the icebox that we were doing, okay? Now, we were having to maybe use, hopefully something was a perfect square, or use the quadratic formula on an icebox, on our other icebox problems, but on KSP, we don't have to worry about that because there's nothing on the bottom. So this makes it a lot easier to solve, okay? So how would I simplify the right side out? So we know the left side is still 1.6 times 10 to the negative 49. What would the right side simplify out into? 4x cubed, okay? So I need to distribute the squared to the 2 and the x. So I get 4x squared times x is 4x cubed. Now I need to divide each side by 4, correct? So 4 times 10 to the negative 50. Now, how would I solve this one in my calculator? Okay, so that's a common mistake if we don't know how to do the cube root. So instead of doing the cube root's the same thing as saying it to the 1/3 power. So if you do 4 times 10 to the negative 50th to the 1/3 power, that's the same thing as the cube root, okay? If it was x to the 6th power, it would be 4.1 times 10 to the negative 50 to the caret 1/6 power. So 4.0 times 10 to the negative 50th to the caret 1/3 power, and that's what x equals. I have not answered my question.
Wait, quick question. You divided the 4, right? Correct?
I divided it by 4, yes, ma'am.
Yeah, okay.
Now, is that my answer?
No,
Yes.
you just said I have no answer between.
Did I say it? Because I just found x. Now, is that the molar solubility? Was it in our first 2 examples, the molar solubility, the same thing as the I of the solid? So that is your answer for that, okay? So whatever this is on this one, you know, when we were doing our other icebox problems, we had to go plug our stuff back in, correct? I didn't ask the concentration of Ag plus, did I? If I would ask for the equilibrium for the concentration of Ag plus, I would have to do 2 times 3.4.
What's this A button?
Give me a second. So, does that make sense to everyone?
Wait, say that again. So what is your answer?
My answer is my x that I got. My answer on this is my answer on this is my x.
So it's 3.4.
4 times 10 to the negative 17. When I've just been doing basic equilibrium, not KSPs, but I've been doing basic equilibrium, I would always ask him for the equilibrium concentrations of things. Okay?
So that's the molar solubility, right?
This is the molar solubility. To find the equilibrium concentration of silver, I would have done 2 times that number. Okay?
Oh, okay.
Any questions about what we've done today?
Yeah, what's this A button?